Hi all, we are Team KNK and we are going to speak about Covatchbot, a smart screening and door security alert system with detection of mask, temperature and sanitization. So every day frontline warriors, they have to stand in front of entrances for the purpose of screening the people. But that will not be safer for them. They have to face some health consequences also. So we are having a better idea for this. So we have proposed an AI and IoT integrated smart screening and door security alert system with direction of MTS, as I said, mask, temperature, and sanitization. So only if the user passes all these parameters, then the door will be automatically unlocked. Looking at the block diagram, Raspberry Pi microcontroller has been used, and to interface components like camera, speaker, Raspberry Pi microcontroller is more easier to work with and it is feasible. That's why we have gone for it. And now, so going with the acronym MTS. So for mask detection, we have used Raspberry Pi camera, and to implement it, we have used deep learning algorithm. Next, for non-contactless temperature measurement, we are using MLX IR sensor, and to interface it with our microcontroller, we have used an IR interface. And thirdly, we use alcohol sensor to check if the person has sanitized their hands, and again an interface for it. So information regarding all these three will be sent to a Firebase database using Wi-Fi and Firebase. From the Firebase, data will be fetched and it will be displayed in the Flutter app that we have created. And lastly, we have LCD and speaker to display and combine necessary instructions for the user.
We have created a 3D model setup. Our project can be placed in a mall or a hospital or in commercial places, even in a house. So consider this building as an hospital, and our co-watch bot is placed in front of the hospital to monitor the people who are trying to enter the hospital. So we have a speaker and an LCD screen to instruct the person to do the following. First, we'll ask the person to face the camera, and the camera, with the help of the YOLO V3 deep learning module, it senses whether the person is wearing a mask or not, and it takes a picture of it. And next, the speaker instructs the person to sanitize his hands. With the help of sanitizer, they can sanitize, and when they place the hand before this alcohol sensor, it confirms that the person has sanitized. And next, it asks the person to place his hands near the temperature sensor, so it measures his body temperature. And all these details, like a picture and whether he has sanitized or not and the temperature, will be directly sent to the person in charge of the hospital or the building through our Covatchbot app itself, which has a simple UI with all these informations. Once when the person clicks the allow button, the door will be automatically unlocked and the person can enter the hospital or building.
Now, let's see about the deep learning algorithm what we have used. We have trained a YOLO V3 model to detect whether a person wore a mask or not. If a person doesn't wear the mask, he will be classified as those who are not wearing the mask with a higher confidence level. Also, if a person wears the mask, he will be classified as those persons who are wearing the mask with a higher confidence level. Also, if a particular person doesn't wear the mask properly, he will even be classified as those who are not wearing the mask. We have used this YOLO V3 algorithm to determine this. There are several other algorithms like CNN, RNN, sliding object techniques, and so on. The reason why we choose YOLO V3 is it is more faster as well as it is accurate. The picture what is taken here will be sent to an online real-time database called as Firebase immediately. A full-fledged Flutter mobile application has been specifically designed for this particular project, which users can install in their Android or iOS mobile phones and see the pictures and sensor details of those who are entering their buildings. Only if a user clicks allow here, the door will be opened. The communication between the Raspberry Pi microcontroller, which is basically the hardware, and our mobile application is happening through this Firebase database.
Let's look into the simulation part. We have used Proteus design suite to simulate our system. A Raspberry Pi microcontroller is used to which other components are interfaced. The LCD display here instructs the steps to the user. First is the mask detection. A logic state is used to detect mask or no mask. This input would be taken from the machine learning model. Once the person is detected to have worn a mask, it moves on to the next step, sanitization. An MQ2 alcohol sensor is used. This detects alcohol vapor in the air and can thus be used to check if the person has sanitized his hands or not. Since Raspberry Pi libraries for these sensors are not available here in simulation, we couldn't directly interface them. So we have used Arduino to interface these sensors with Raspberry Pi. By changing this logic state, we realize the change in the alcohol content, and a state 1 depicts the presence of alcohol, and the sensor detects it to display that the person has successfully sanitized. Coming to the next step, body temperature, we use MLX 90614, an IR-based non-contact temperature sensor. The body temperature of the person in front can be measured and checked if it's normal. Since here in simulation we couldn't vary and realize the changes, it displays normal body temperature. Once all these steps are successfully passed, it is indicated through the LED here, and a message is sent to the person in charge through our app. Once approved, the person is let in the door. Since we are using simulation environment, we are restricted to using these. This will soon be implemented in hardware, and all these integrated together would produce a secure screening system.